This is a re-recording of the lecture from Thursday morning. So I forgot to press record in Teams, so I'm re-recording the lecture offline. So the topic of today's lecture is from Python to Java. So basically in the next 2 or 3 lectures, I'm going to show you how to do things in Python, and then I'm going to show you how the equivalent thing can be done in Java. Okay, so you know that a Python program starts running from the first line of a Python script, right? So the interpreter will read your Python script and then interpret each line of Python code, right? And that means you can have a program that's just a single line long, right? So the classic hello world program in Python, you can write simply as print and then round brackets hello world inside of quotes of some kind. Right? And if you run that program through the Python interpreter, you'll end up with the string hello world being printed to your screen. Java is different. So in Java, a program always starts running from a method called main. Right? So that's this thing here in red. Right? Now, the other thing that's different is that the main method must belong to a class. It is allowed to belong to something called an interface, but we are not interested in interfaces quite yet in the course. It has to have a specific form. So in other words, your main method has to be declared like that, or like that, right? Now in this, for the main method, these are equivalent. So they're both allowed. The dot 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 means that this method can accept 0 or more arguments of type string, right? So that's the other difference between, that's another difference between Java and Python, right? This sort of looks like a Python function declaration. In Java, we say that it's a method. We call this the method header, right? You notice that in Java, you have to say what the type is of that argument. So I'll explain more about that later on. So string dot 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 means 0 or more strings. String square bracket means an array of strings, right? So an array is similar, but not the same thing as a Python list, right? Both forms are legal for our purposes right now. It doesn't matter which one you use. Now, the main method has to be inside of a class. So this declaration public class hello world, that says that we're defining the class named hello world. So the class name shown in red, the rules are that it must begin with what's called a Java letter. The easiest for our purposes, just assume that it has to start with a letter. The other characters in the word can be letters or numbers, or the underscore, but you should avoid the underscore except in unusual cases. Java has some very strong programming conventions. So a convention is a rule that programmers follow that's not necessarily enforced by the language. So Java programmers name their classes using what's called upper camelCase, right? So if the first letter of the name is always capitalized, if you have a multi-word name, then each letter of the beginning of a word is capitalized. So again, that's a convention that Java programmers use. There's a good reason for the convention, and it's something that you should follow as well. So Java statements almost always end with a semicolon. Right? That's not exactly true, but it's the easiest way to convey the idea at this point in time. So that's another difference between Python and Java. Right? In Python, you're allowed to put a semicolon at the end of a statement. In Java, you must put the semicolon at the end of a statement. The other difference you may have noticed is how you print something in Java and Python. Right? So in Python, you use the print function. In Java, you have to write something like system.out.println. Right, and I'll explain a little bit more about this shortly. So a string literal in Python can be single quoted, right, double quoted, or triple single quoted. Actually, it can be triple single quoted or triple double quoted. So a literal is a value that you can write down, right? So it's not a variable, right? It's a value you can write down, right? So these, that's hello world in 3 different languages. Right? In Java, string literals can only be double quoted, right? So that's the only, using double quotes is the only way, is the only legal way in Java to define a string literal, right? Now, printing stuff. So Python's print function is actually very powerful. So if you want to print one or more values in Python, you simply list the values as arguments to the print function, and you separate them with commas. Right? So print 2 and then plus 3 equals 5. Right? Python's print function will print the 2, followed by a separator character. Right? So by default, that's the space. And then plus space 3 space equals space 5. And then it'll go to the next line. Right? So the next line of output will appear here. And you can control that as well, right? So the print function, you can tell print what to use for the line terminator, right? Java's print line method, so that's print ln, it only accepts one argument. So if you want to print out something like 2 plus 3 equals 5, and you have all of these values stored separately, right? So 2 plus 3 equals 5, right? Then you have to do something else. So for example, you can use string concatenation to compute the string that you want to print, right? So you can write 2 and then plus the string plus, right? And then concatenate that with a 3, and then concatenate that with equals, and then concatenate that with 5. So that will generate the same string there as you see here. Right? Print ln, right, will go to the next line. So the next line of output will appear on the next line. There's a similar method just called system.out.print, right, and that one will not go to the next line. So the next output will come immediately after the 5, right? So there's print and print ln. And unfortunately, you have to write system.out. in front of all of that. So that's another difference between Python and Java, right? Printing something in Python, in Java, right, is it's a little more verbose than printing something in Python. So in Python, variables have no type associated with the variable name. Excuse me. Instead, the types are associated with the objects, right? So hello world, that's actually a string object of some kind. Right? 123, that's an int object of some kind. Square bracket 123, that's a list object. In Python, you can store whatever you want in a variable. Right? So I can store the string hello world in S. That's not exactly true. So I'm not storing the string in S. I'm actually storing a reference to the string in S. And I'll talk more about references in the next lecture. 123. So I can store a reference to an int object in S. And then I can store a reference to a list object in S. Right? And I don't have to do anything special to do so. Right? I just write S gets the value of whatever. Right? Now in Java, things are different. So in Java, variables have a type. Right? So if I want to make a string variable called S, I have to tell the compiler that I want S to be a variable of type string. Right? So when you first use the variable, you have to also say what its type is. Right? So the type is declared along with the variable name. Once you create a variable, its type can't be changed. Right? So on this page of code, right? S is always a string variable, right? I'm not allowed to change its type. And then finally, a variable can hold values only of its declared type. Right? So that's not precisely true, but for now, let's just assume that's true. Right? So on this page of code, whenever I use S, right, if I want to store something, I always store a reference to a string object. Right? I can't put in, for example, the int value 123 and store it in S. Right? So here I've got a variable called t. Right? This is the first time I'm using the variable, so I have to say what its type is. Right? So it's the int variable t, and I can store int values in t. Right? So I can store the value 123. Here I've got a variable called a list, and its type is big list integer. So this is another difference between Python and Java. So the list type in Java is called big L list. This funny less than and then greater than and integer in between, that says that a list is a list of integer values. Right? So using a list, I can only put int values into a list. So for example, I can add the value 1 to the list, I can add the value 2 to the list, and I can add the value 3 to the list, right? And that produces a list similar to that Python list. During the actual lecture, someone asked, can you create a list where you can put anything into the list? Right? The answer is yes. So you can make what's called a list of big O object, and then you can put in almost anything into that list. We'll talk more about Java lists in a couple of lectures. Java variable names also have there are some rules for naming the variables, and there's also a convention. Okay, so the rule is a Java variable name must begin with the letter. The convention is that it always begins with a lowercase letter. Right? So here I've got lowercase s, I have lowercase t, I have lowercase a, and then capital L list. Right? So by convention, if you have a multi-word variable name, you should use what's called lower camelCase. Right? So the first letter of the name is in lowercase. All the other words of the name are capitalized. Right? They start with a capital letter. This is a convention, right? So it's not a rule. In other words, the compiler doesn't care if you name it this way, right? But other Java programmers are expecting you to name your variables like this. You are allowed to use numbers and the underscore in a variable name. But the first character of the name must always begin with the letter. Generally, you should avoid the underscore unless you have a good reason to use it. Right? So in other words, don't use it by habit. Comments in Python, there's only one type of true comment in Python, right? So that's the line ending comment, right? And it always starts with a hashtag or pound symbol, right? So here I've got the comment initial investment. Here I've got the comment annual interest rate in percent. Right, and here I've got a comment after some code, right? That's fine too, right? The end of the comment ends the line, right? So the comment ends the line that it's on, right? Everything in the comment is ignored, right? So the interpreter ignores all of that, it ignores all of that, and it ignores all of that. In this example here, simply is a compound interest example. Now, it doesn't matter if you know what compound interest is. If you haven't seen it before, it's not important. This is my initial investment, so $100, for example. That's my annual interest rate, so that's actually 1.25%. Right? After 10 years, right, my total investment is worth this much. Right? So the principal, 100, times 1 plus the interest rate, right, raised to the power 10. Right? So all of that is raised to the power 10, and then we multiply by the principal. An inline Java comment starts with // right, and ends the line that it's on. So / is the comment in Java that's similar to a Python comment. right? So this is the exact same example done in Java, right? So notice again, I have a variable p. This is the first time I'm using it, so I have to say what its type is. So the usual floating point type that you would use in Java is called double, little d, double. The interest rate is R, right? This is the first time I'm using R, so I have to say what its type is, right? Here's final value. Notice that it's written differently than in Python, right? So in Python, it's not unusual to see underscores in names. In Java, the convention is to use lower camelCase, right? So no underscore and the V is capitalized. This is the first time I'm using the variable, so again, I have to say what its type is. There's no exponentiation operator in Java, so I have to use a method to compute this quantity raised to the power 10. So the method is named bigmmath.pow. Java also has multi-line comments. So a multi-line comment starts with /*. It continues for as many lines as you want until the first */. So there's a so that's a 2-line comment right there. The multi-line comment, or this form of commenting, you're allowed to insert into the middle of most statements. The one place you can't put it is in the middle of a string. So if you put it in the middle of a string, it just becomes part of the string, right? But you can insert it almost anywhere else, right? So for example, here I can put it in between the assignment operator and the value on the right-hand side of the assignment operator, right? And that works just fine. So the compiler ignores everything that's part of the comment. As I mentioned before, there is no exponentiation operator in Java. You have to use math.pow instead. So Python does have types, and it has literals. All right. So remember again, a literal is a value that you can write down. So some common Python types are shown here, right? So if I want a true/false value, right, I can use a capital T true, right, and I can use capital F false, right, and those are called bool. In the type is called bool in Python, right? But those are your Boolean or logical types. Boolean or logical values. If you just have a number with no decimal in it, in Python that's an int, right? If you have a number with a decimal in it, in Python that's not a double, sorry, that's a float. Something inside single quotes is a string, right? Empty or something inside of square brackets is a list. So the corresponding Java types and literals. So your true/false type in Java is called Boolean, right? Its values are little t true and little f false, right? Any number with no decimal is no decimal. Yeah, any number with no decimal is an int. Any number with a decimal is a double. Anything inside double quotes is a string. And there is no list literal in Java, right? And similarly, the list type always has the element type associated with it. Again, we'll talk about lists in a later lecture. So this is probably, so everything I've talked about so far, the differences between Python and Java are more or less one of syntax, right? So the names are a little bit different, how you write things down are a little different. But you can, everything I've shown you so far, I think you can figure out, if you looked at the Java, you could sort of guess at what it means in Python. Right? This is the first major difference between the two languages that I'm going to talk about. So in Python, everything is a reference type. Right? So values are actually references to objects. So for example, when I write TF gets the value true, right? What's really happening is there's some object that represents the bool value true, right? And the variable TF, that's a reference to that object, right? When I write X gets the value 1, right? There's some object in memory that represents the int value 1, right? And X is a reference to that object, right? So X doesn't store the value 1. TF does not store the value true, right? So instead, TF points to or refers to some object whose value is true. x points to or refers to some object whose value is 1. Right? So Java also has reference types. Right? So anything that begins with a capital letter, a Java programmer will assume is a reference type. So big S string, that's a reference type. Big L list is a reference type. Big A array list is a reference type. Right? Now remember earlier I told you that classes should always be named with an uppercase letter. Well, it turns out that classes are user-defined reference types. Right? So our hello world program actually defines a type called big H hello world. Right? So it's in principle possible to create a hello world object. Right? And that's why Java programmers use the convention that class names should always begin with a capital letter. Right? So that's so that it looks like a reference type. Now Java also has a second kind of type called a primitive type. Right? So any type that begins with a lowercase letter is a Java programmer will automatically assume is a primitive type. Right? So things like Boolean, int, and double, those are all primitive types. Right? And I'll explain what the difference is between primitive and reference type momentarily. Right? Now this also explains why the naming convention for classes exists. Right? So if you name your class with a lowercase letter, right, and you use it as a type, that looks like a primitive type to a Java programmer. Now, an experienced programmer will recognize fairly quickly that it's not in fact a primitive type because an experienced programmer knows there are only 8 primitive types in Java, and there's no way for the programmer to create additional primitive types. Right? So the type Boolean, those are your true-false types. That's your type that can store a true-false value. Right? Byte, char, short, int, and long, those are all integer values. Right? And float and double, those are your floating point values. In Java, normally, if you need an int value, you use int. Right? If you need bigger int values, you use long. If you're representing characters, so individual characters of a string, you use char. But underneath the hood, that's actually an integer value. In Java, you normally use double for floating point values. Right? The main reason you would use float is if you want to conserve memory and you're not concerned about the lack of precision you get when you use float compared to double. But I'll explain more about that later on. All right, so reference variables store references to objects, right? And in Python, all variables store references, right? In other words, they don't store the actual value, right? So x does not store the value 1. X is a reference to an int object, right? Y does not store the value 1.0, right? Y is a reference to a float object. And S does not store the string hello, right? S is a reference to some string object. And in Python, the type is actually str. Now, the primitive type variables, they actually store a primitive value, right? So in Java, when I write int x gets the value 1, right? That means x stores the value 1, right? So whenever I say x, I mean the value, I'm going to get the value 1. Double y gets the value 1.0 means that y stores the value 1.0. Reference types in Java behave the same as reference types in Python, right? So the variable s is a reference variable, right? So s stores a reference to some string object whose value is hello. All of the primitive types occupy a defined and fixed amount of memory, right? So this is important. So Java says, right, how much memory each primitive type occupies. Different primitive types occupy different amounts of memory, right? So an int occupies less memory than a long. A float occupies less memory than a double, right? Now, these two things have a bunch of different implications, right? So if an int occupies a fixed amount of memory, right, then by definition, there are only a finite number of ints, right? Because the amount of memory is fixed and finite. So I can only represent a finite number of different ints. That means there has to be some integer value, some smallest integer value, and some largest integer value, right? And that's true of all of the primitive types. Okay, so if you want to do calculations involving integer values, then int is the usual choice, right? Now, it has a smallest value and a largest value. So the smallest int value, or the most negative int value, is defined by that constant right there, right? So integer dot, all caps min value. So whenever you see something in all caps, and if it has an underscore in the name, that indicates that it's probably a constant. Right, so the smallest or most negative integer value that you can store is defined by that constant there. The largest int value that you can store is defined by that constant there. Right, those are the actual numbers. Right, that's minus 2 to the power 31, and that's 2 to the power 31 minus 1. Right, you don't have to remember what these are, right? What their actual values are. You can always get them using the named constants there. So an int literal is any number written without using a decimal and not ending in capital L or lowercase l, right? If it ends in capital L or lowercase l, right? So if it's a number that ends in capital L or lowercase l and it doesn't have a decimal in it, then that's a long literal. Right? So int literals are just plain integer values. Right? If you try to write down an int literal that's more negative than that or more positive than that, right? The compiler will flag that as an error. Right? So you cannot write down a literal that is outside of this range. Right? The compiler won't let you. If you try to do so, the compiler will say that's an error. Right, so minus 1, that's an int. 99 is an int. 98 is an int. 1 is an int. 0 is an int. In Java, you're allowed to use underscores in the literal. You're not allowed to use the underscore at the beginning or end of the literal. Right, so for 1 million, I can insert an underscore after the 1 and after the first 3 zeros. Right, and the reason for doing so is to make it reading large literals easier. If you happen to know about binary, octal, and hexadecimal values, there is a way to write those literals in Java, but for our purposes, they're not relevant right now. So arithmetic in Java that involves 2 int values is said to be closed, right? And so what that means is if I add or subtract or multiply 2 int values, I always get back an int value, right? Now, that's not very surprising except for division, right? So, for example, if I take 1 and divide it by 2, right, I don't get back 0.5 in Java. I get back an int value instead, right? And that's very different than Python, right? So 1 divided by 2 in Python is 0.5. In Java, it's something else. So in Java, division is performed using what's called truncating division, right? So you compute the quotient and then throw away the fractional part. So I'll give you an example of that in a second. Here we have the values 1, 3, and 13, right? So x plus y, that's just 1 plus 3, so that's 4, right? X minus y is just 1 minus 3, so that's minus 2, right? Now division, right? So 1 divided by 3. So I compute 1 divided by 3, that's 0.33333, right? Throw away the 0.3333, and you get 0, right? 13 divided by 3 is 4 and a bit, right? So, or 4 and a third. So throw away the and a third, and you get 4, right? You can use parentheses to force the addition to happen before division. Right? So precedence rules also apply here, right? So addition normally has lower precedence than division. So if I want to add x, y, and z together and then divide by 3, I can put everything in parentheses. Right? X plus y plus z, that's 4 and 13, so that's 17. So that's an int. Divided by 3 is 5 and a bit, so I get 5. Now, the closure property says that if I perform arithmetic with 2 int values, I have to get back an int value. So now the question is what happens if I have 2 int values, I add them together, but the resulting value does not fit inside the range of int. Right? So for example, if I start out with the largest int value and I add 1, right? So closure says I have to get back an int value, but I can't represent x plus 1, right? So something else has to happen. So in Java, the something else is you wrap around to the other end of the range, right? So if this is integer min value and this is integer max value, right? So if I start here and I add 1, right? There's no value over here. So what happens is you wrap around to the other side and you get integer min value, right? If I do x plus 2, I start at the largest int value and then I want to go over 2 spaces, right? But there's nothing over here because this is the largest int value. So I wrap around once and then I go to the next value, right? So that's integer min value plus 1. X plus 3, so I start out at the largest int value and I go over 3 spaces, but they're not here. So instead I wrap around and then go over 2 spaces, right, to get integer max min value plus 2. The same thing happens if I'm at the other end of the range, right? So if I'm at integer min value and I subtract 1, well, there's no value over here. So I go around to the other side and I get integer max value, right? So integer min value minus 2, I want to go over 2 places. There's nothing over here, so I wrap around and then go over 1 place to get integer max value minus 1. Right? And the same thing happens for x minus 3. Right? Multiplication is similar, right? So if I have a large value multiplied by another large value, right? You want to go over somewhere way over here, but these values don't exist. So you wrap around over here and then complete the rest of the calculation. Okay, so if you to visualize this with a smaller example, right? Let's imagine that Java had a type called small int, right? So the minimum value of small int is minus 2. The maximum value of small int is 2, right? So in other words, a small int can take on the values minus 2, minus 1, 0, 1, 2, right? And now I'm just going to write this down repeatedly, right? And so imagine that this sequence extends infinitely, right? So what happens when I do 0 plus 1, right? So when I add 1, I want to go to the number to the right, right? So I get 1, right? 1 plus 1, well, I want to go to the number to the right, so that's 2, right? Now 2 is the largest small int value. So if I add 1 to 2, what happens? Well, I go to minus 2, right? So that's wrapping around, right? So what happens if I add 1 to minus 2? I go to minus 1. Add 1, I go to 0. Add 1, I go to 1. Add 1, I go to 2, right? Add 1 again, well, I go to minus 2 again, right? Subtraction works the same way. 0 minus 1, I go to the position to the left, right? Minus 1, I go to the position to the left to get minus 2. Now, minus 2, that's the smallest small int value. So if I try to subtract 1 from minus 2, I wrap around and go to 2, right? Multiplication works the same way. So 2 times 2 is 4, right? So I want to move, actually, 2 times 2 is 4. So 2 times 2 is adding 2 twice, right? So plus 1, plus 2, plus 1, plus 2. So I get 1. And so that's how overflow works with the int, with int. And this is true for all of the integer types, right? All the primitive integer types have this overflow property. So integer overflow occurs when an arithmetic calculation with an integer type results in a value that is outside the range that can be represented by that type. right? So in Java, wrapping occurs, but different results occur in other programming languages, right? So the closure property says that I have to get back. So if I perform arithmetic with two ints, I have to get back an int value, right? Now, if the value can't be represented inside the range of int, something has to happen, right? So the way that the Java language is designed, wrapping occurs, and it occurs silently, right? So the compiler doesn't tell you that this happens. The Java runtime or virtual machine doesn't tell you that this is happening, and no error occurs, right? Some other languages, something else might happen, right? So for example, in some languages, that might result in an error instead, right? And the program may stop when that happens. So integer overflow occurs because these values occupy a fixed amount of memory, right? One of the reasons for doing so is that it's easy to make hardware that, well, it's easier to make hardware that works with fixed ranges of values, right? Now in Python, the int type can take on arbitrarily large values, right? So it can take on values, it can take on values that occupy up to all of the memory that's available on your computer, right? So in other words, the size of an int in Python changes or can change, right? But that's much harder to do in hardware, right? Yeah, so we'll just leave it for that for now. Now, integer overflow has been the cause of many infamous and unfortunate events in some cases. So Ariane 5, that's the European Space Agency rocket. Its predecessor was Ariane 4. So when they made Ariane 5, they took a lot of the software for Ariane 4 and ported it over to Ariane 5. Now, one of the problems is Ariane 5 is a much bigger rocket than Ariane 4. During launch of Ariane 5, during the first launch of Ariane 5, there's some value that's being calculated using some sort of int type. And because Ariane 5 is a much bigger rocket, the values that were being computed were much larger compared to Ariane 4, and overflow occurred. That eventually ended up shutting down the launch computer, I believe. If you click the link, you can find the details. And that caused the rocket launch to abort, and the rocket crashed, right? Which is a many, many millions of dollars error. Deep Impact, it's a satellite that was sent out, I believe, to crash into an asteroid. It also had an integer overflow bug that ended up causing contact to be lost with the satellite and the mission to terminate in failure. So again, another many millions of dollar failure. Therac 25 is a very sad story. It was a radiation treatment device for humans. So it had many errors. Integer overflow was one of them. Taken together, all of the various errors ended up causing very large radiation overdoses in many patients. And some patients actually died because of the overdose. Your GPS, the GPS satellite system, it has an integer overflow issue. It's a known issue, so it doesn't cause the GPS system to crash. But every couple of weeks, something has to happen to the way that the GPS system keeps track of the day. I believe the day. Again, hit the link and you can find out more about it. The year 2000 problem is a problem. Well, it's a very famous problem that was before many of you were born. So the year 2000 problem stems from the fact that a lot of banking and financial software stored dates, stored the years with only 2 digits of the year, right? For example, the year 1995 would have been represented by the number 95, right? Now, that's a problem when you get to the year 2000 because now the range of numbers overflows, right? There is no 100, there is no year, because you're only using 2 digits to store the date, the year 2000 now looks like the year 00. But that's also the same as the year 1900, right? Now, if you're storing the age of a person or the birth date of a person, right, that's a problem because there are many people alive at the time who were born in 1900 or earlier, right? Uh, and so this became a huge problem. Oh, there's another problem occurs, right? So if you go from 99 to 0, right? So if you're trying to perform some sort of interest calculation, because this is all financial, right? You now have this big problem because now it looks like uh, either it doesn't look like 1 year has elapsed, right? Something weird has happened. You've gone from 99 to 0. So it looks like 99 years have disappeared. And so there was a huge effort undertaken to retrofit a lot of financial software to avoid this problem. The year 2038 is a time problem. So it's related to how computers or certain operating systems store time. And it turns out sometime in the year 2038, the largest value that can be stored is going to be exceeded. So now it looks like the time is now going to go from the largest value around to the smallest value. So there's another related problem that's going to happen 15 or so years from now. Again, you can follow these links and find out more about them if you're curious. So that's where I got to in the lecture today. And so I'll just end that here, and hopefully I'll remember to record the lecture tomorrow.